let's get into the next relationship. It's dependency. What's dependency? This is a relationship that is used to describe the unidirectional relationship between classes. It's a common relationship between classes. For example, let's say it's you, a person. There's an object, and there we have cars, objects, food, or whatever. And a person could make an operation, could perform operation to the car. For example, a person could buy a car. A person could buy food. So the buy this operation is the relationship between the person and the car. This relationship we name as dependency. Remember, this relationship is unidirectional. It points from the person, from the object who performed the operation to the target, to the car, to the food. So person can buy the car, person could buy the food, but you cannot reverse this relationship. So car could not buy person. That's ridiculous. This is the relationship of dependency. And it's very common. Different objects, they may have something connect with each other, such as buy, such as read, such as use. Yeah, so it's a very common relationship between objects. So how to describe this relationship in UML? We use an arrow. And the arrow point from the object that performs the operation to the target. For example, here, a person buy car, a person buy food. So use the arrows point from the person, from the object to its target. It's this arrow, we use this symbol in UML describe dependency. And inside the object that performs the operation, we should add method. Add this operation is buy. So add the buy method inside this block. This block, as we know, we put all these member methods here. So this is the symbol in UML. And the right side is a code. So we have class, but the person is a class, so that and inside the class we define two methods. One is by, another is the same name. And the same method but with different parameters inside the parameterization size. We will name it as overloading. In the future class, we'll discuss it more. Here we know that we buy different things, so these objects as a target of the operation, we put this object into the parameter size as parameter to the method, to the buy. So inside the code, we describe this dependency as the method invocation. At the method, put this target as a parameter to the operations. And the operation method, we put them into the class. This is dependency. Okay, so the next relationship is interface. It's a little bit tough relationship because it's it's complex and it's not easy to understand them well. So we have a full chapter content to discuss this specified relationship. And here, what you should do is understand the basic idea of this relationship. The name is interface, or we name it as interface inheritance. That means an interface is a device. That the device that makes unrelated objects to interact with each other. What does it mean? Unrelated objects interact with each other. It's just the protocol or agreement on the behavior. For example, now I have rider and I have bicycle. The rider and bicycle, how the two objects connect with each other? We use interface. The interface defines change gear or brake or other operations. So we use the interface, and inside the bicycle objects we give the implementation of these methods. And the rider, it don't know how these methods are implemented inside the object, inside the bicycle, but it could use them. So use interface as a device can interact with each other. This is important for us, so we can use this to build a connection between different objects. This is one of the ideas. Another idea is here's a bicycles. Well, we have other classes that are not bicycles, but they are not to implement the same interface. So the other kind of class, although they're not a bicycle, but they still can implement the same interface as a bicycle. So these different objects, they become the similar objects because they implement the same interface. I will give the example for it. Now we have a bicycle here and I have a door. They're total different objects. The bicycle is for transportation, a door is element of house. They're different. But here we make them to implement the same interface. The interface, the name is bell. And inside the interface, there is a method. We give its name as ring bell. And ring bell is only the operation framework. Inside a ring bell, we don't have any code for it. But the bicycle and the door, they both implement the same interface. So inside the bicycle and the door, inside the code, they have to implement the ring bell method and give its own code. Maybe the code is different because we install a bell on a bicycle, and there is a bell and door, a bell for bicycle and a bell for door. Maybe it is implementation are different. So we give its own code for the different designing. So this is how to implement the method, implement the interface inside the class. So use the symbol. The symbol is the same as the inheritance to describe the interface implementation, but different from the class inheritance. The interface, it looks like the same as the class blocks, but the first block inside the class, we only have the name of class. But in the interface, we add extra information. We use a brackets. Inside, we give its name as interface. It marked as the bell is not a common class, it's an interface. It's different from the class diagram. It's an interface. But this sign is the same. We use arrow. And as arrow, we used objects which as a class which want to implement the interface. We use arrows to point to the interface. The bicycle will implement the bell interface and door at the same time. It wants to implement the same interface bell. So the symbol is the same. The arrow is the same. But you must remember different from the class inheritance. Here is interface inheritance. So the interface, the bicycle and door, because they are all implementing the same interface. At its view, they are the same. So the interface build a similarity between the different class of bicycle and door or other kind of things. This is the first important point for this idea. And another, because a bicycle and a door, the two objects both implemented the bell interface. So once we create object from the bicycle, from the door, the two objects is similar. That means they can pass as a parameter to the operation. Suppose here we are another object is person. The person here and the person can make some kind of operation to the bell. For example, push. So push. This operation's name is push. And then push the bell. The push the bell so we can pass the bicycle or the door. Once we get object, we'll pass the bicycle into this operation as parameters. And or we pass a door, an object of a door, to operation. So a man, a person, can push a bell and a bicycle. They can push a bell and a door. It's the same. To the person, you all have the same operation to do the push operation, to push a bell, because at the parameter, they are the same. So we name it as pluggability. It's a very important feature brought by the interface inheritance. So this maybe it's a little bit hard, a little bit tough to understand at this time, but in the future, we have a full chapter to discuss this concept. We will give more examples to explain how to use this interface to solve your problem in the real world.